Hi, last time we made the game go with the step function. Let me see. Here we are. The step function makes the cells change state according to their neighbors with the rules of the game of life. But the board is unbounded, but we cannot see the rest of the board. So let's add some zoom and pan capabilities. Let's see. For that, we need to add a camera with offset initially 0 and zoom initially 1. The zoom and offset are defined in this struct which Raylib provides. We need offset the target, sorry, this is vector 2, 0, 0. Okay, and we need the offset is in 0, the target initially, I think it doesn't matter because we will modify with the mouse input. So yeah, rotation we don't need, although perhaps we add it later. And the zoom initially will be 1. What we need to do is to add, let me see, get wheel mouse move. If this is not 0, we need to set the offset and the target. And the target will be the screen to world to the. This function calculates given an absolute position, like the mouse position in this case. It gives the position in the world, in the logic world, given the properties of the camera, and the target will be the center for the zoom, and the offset is the mouse position, and we need to check if this is negative. We need to multiply the zoom by something less than 0, for example this, and else this will be positive because we are postulating here that this is different than 0. Let's divide, let's use the same number here to achieve consistent zoom. Okay, this obviously will not have any effect yet because we are not taking into account the camera. So in the drawing part, this is the input part. In the drawing part, we need to begin the mode 2D with the camera. And after we draw the board, we end the mode 2D. And obviously, this will allow us to zoom. But as you see, we are not inputting anything. In reality, we are, but we are not seeing it because the input also required to use the camera. Let's use a reference. And when we get the mouse position, we need to do the same. Let's screen to world 2D and use the mouse position and the camera. And this, I think, let me see, we have an error here. Because obviously we are not passing the camera here. I think we should, no, it's sufficient to pass the camera. Let's see. We are not, we are missing something. I think, yeah. We need to specify the rotation of the camera. Yeah, because, yeah, now it works. Because D has an interesting property of floating point numbers, which is if you don't initialize them, they begin as not a number value by default. This is a bit weird about D, but it's interesting to have that feature sometimes, because obviously you don't notice, when you don't notice it, things will not work, like in this case, and you hopefully realize that something is wrong. So let's see, we have zoom in, perfect, and it obeys the mouse, perfect, and we zoom out. Okay, the thing is that obviously things are, let's see if we add a little rotation, only to check if it works. Let's add a key here, like for example this, and the E key rotate to the other side. Let's see what happens here. Key, sorry, KQ, KQ, and KE. Let's see what it works. And the rotation also works. The rotation is relative to the 0 position, I think, which is, yeah, it's not the center of the screen. So we need to add the input for the panning. Let's use the right button for this. We need to use the delta. Delta is the vector or the distance the mouse moved. We need to divide it by the camera zoom to adjust for the size of the world, and target will be, yeah, we need to add that delta. Let's see, we are moving in reverse. And the delta, the rotation obeys the last zoom we made. Let's add, this is down, so we can rotate continuously. Okay, the panning is inverted, so let's do that. Okay, perfect. And if we are zooming, the panning will be proportional to the mouse. Perfect. Let's use this rotation is, I think this in degrees, or in degrees. Okay, yeah, let's. I never saw a game of life rotating before, but yeah. Okay, let's check. You know what? Let's add a function to populate an area with random cells. Let's put it here. Let's copy. Let's copy this to begin with. Put random cells. This is not necessary. And let's see. We will make a for each. Let's input 100 random cells and use the position P as a center. Let's see. Float X. No, angle, and the angle will be between 0 and tau. Tau is 2 pi, basically. It's an entire term. I think it's not defined here, but yeah, let's define it 2 pi. Okay. The angle dot y equal sin angle, and let's have, for example, radius will be uniform between 0 or between 1 and let's say 20, and let's multiply. You know what? Let's take this. Let's round it so we have that, and we need to set the cell. You know what? Let's make an auxiliary function so we don't repeat this. Let's cell pos and or better change cell. Okay. And in the change cell function, we do this. We need the point pos. I think this will be equivalent. Raylib. Yeah, there was another. Okay, this is working. So the change cell we will use here point x, y. So this, obviously we don't have yet the input to do this. So let's add it. We could use change cell. Yeah, if is key down left control, for example. Let's call it this. And if not, we change one cell. So what happens here? Input random cells. You know what? Yeah, we don't need it. We don't need this. We need the position and yeah, okay. So we draw individual cells, but if we hold the control button, we paint random cells. Okay, interesting. Let's, you know what? We can use the camera. We can pass the radius here. And this will be 20 times the camera zoom, for example. And here, okay, this, we need to pass the maximum between 2 and the max radius, just in case, because this could be less than 1. So let's see. By default, it's inverted, sorry. This here, input cells 20 over camera zoom. Okay, so we need by default 20, and if we are zooming out, we have we have less density, obviously, when we are zoomed out, but yeah, it's no problem. And if we are zoomed in, let's see, in an empty region, if we zoom in more, yeah, the circle is interesting. Okay, this is nice. So obviously the rules of life are a bit a bit sparse, but let's add some splotches here and there. You know what? The quantity, the random cells, we should use also the quantity, number of cells, and here we need to round it. So we draw 100 here, less than 100 here, less than 100, okay. Okay, nice. Interesting. As we zoom out, this is an interesting phenomenon, which, as you see, the density is bigger, is higher at the center of the random circle, because we are choosing the radius of the random cells uniformly, no? But yeah, this should be different, but we can left it as an exercise for next session. In the next session, I will do rudimentary load and save features, so we can run our models, our worlds, and save them to disk, and then restore them when we want to rerun them. It's very funny to see the world rotating. Okay, this is funny. This is a bug. When we rotate, we lose the, yeah, we need to translate also the mouse the mouse delta, but yeah. Okay, again, thanks for watching. Let me know of any ideas or comments. Please like and subscribe, and consider supporting me using some of the links below. Thanks.